All right, and we're going to look at chapter 1 today. And 1.1 is functions. And you should be able to describe subsets of real numbers. So it'll take about 2 days for this one. So here, um, we need to think about what real numbers are. So real numbers are basically uh, any number you can think of, um, with the exception of imaginary numbers. All right. So we have we have rational numbers. Rational numbers, they are all numbers that can be put uh, in decimal form or fraction form, and then they are eventually going to repeat. That's going to be a decimal number that eventually repeats or stops, or yeah. Okay, now irrational numbers are those numbers um, that go on forever. Okay, so you can't put it in decimal form, and it's going to be a decimal. Sorry, you can't put it in fraction form, and then in the decimal form of it just keeps going forever and doesn't stop. So common examples of those are square root of 2, square root of 3, uh, pi, e, all those numbers. Integers, they're like whole numbers, including a 0 that has positive and negative numbers. Okay, and whole numbers, uh, just the counting numbers plus 0. So 0, 1, 2, 3, 4, 5, 6, 7, etc. All positive numbers. Then natural numbers, counting numbers. So 1, 2, 3, 4, 5, 6, 7, all the way to infinity. Okay. And those are the ways to write them. So, uh, and the book kind of writes it fancy. Here, just write a Q, you write Q, Q, and then you put a line through it. Irrational, looks like a Roman numeral 2. Z, you just put a double line there. Whole numbers, you just put another line there. And natural numbers, put another line there. That's it. All right. So we have, we're going to look at two different notations today. The first one is set builder notation, and that's where we have our variable first. Okay, so first you need the fancy brackets. So notice that we have those fancy brackets in between, and then you have that variable. And then this means such that, okay, so the variable and then the line such that, and then you have your rule. Okay, kind of like an expression. So x is greater than or equal to -3, but less than or equal to 16. And then comma, and you're going to have that variable is an element of. An element of, and then you put the type of number it is. So here you could put um, set of numbers. This is where you would put rationals, irrationals, integers, whatever, any set of numbers. Okay, and that's that. So let's put this in the notes. Let's pause because the notes are taking a while. All right. And here's some examples. And then we're going to look at interval notation as well. So interval notation is kind of smaller. You just have an interval from one to another. Okay. And you're either going to have the rounded parentheses, or you're going to have brackets. Okay. Or you can have the combination of both. Okay. So the rounded parentheses, it means it includes, sorry, it doesn't include. And then the bracket means it includes that number. Okay. So, or equal to's basically. So interval notation, you have the smallest number it could be to the biggest number. So smallest, comma, biggest. All right. And they give some examples there, or the general form. X is greater than or equal to A and less than or equal to B. Because of that or equal to, we have brackets. Okay. And if you have less than or greater than, you would have parentheses, just like over there. And you can also have a combination of both. All right. Now, whenever you have infinities, infinity or negative infinity, you're always going to have, will always be parentheses. Okay. So wherever you have the infinities, you're always going to have the parentheses. So just like over here, we have a negative infinity. So it's parentheses. Positive infinity, parentheses. So the smallest number could be is the first, and then the biggest number could be is the last number. All right, so there was an example there. And here we go. So it says write each set of numbers in set builder and interval notation if possible. So let's do this. I'm going to crop this one. All right, so what is our variable? Our variable is x. And then we want such that, and then we put our rule, x is greater than 50. And what numbers are those? That's going to be comma. That one's going to be all real numbers. So x is an element of all real numbers. It's R with a line through it. Okay. And that's set builder notation. Interval notation, because there's no or equal to there, that means we're going to have parentheses. Okay. So this is x is greater than 50. Since it's greater than 50, that means all the numbers are going to be bigger than 50. So 50 is the smallest number. Okay, so even though it says greater than, this number that they gave us is the smallest number. So that's going to be on the left side. So 50. And they don't give us the biggest number because it goes on forever. So since it goes on forever, the biggest number is going to be is positive infinity. Now you don't need to put the positive there, but I like to put it there. And infinity always has that parentheses. And there you go. All right. And then likewise, number 2, you have the variable x such that, and you put the rule, x is less than negative 13, comma, and x is an element of real numbers. And there you go. And then for the interval notation, so here it says x is less than negative 13, so that means negative 13 is going to be the biggest number. We want numbers that are smaller than negative 13. So this is the biggest. All right. So that means this would be here. And because there's no or equal to, that means it's parentheses. And the smallest number is all the way to negative infinity. Okay, so if there's no barrier for the smallest number, it's going to be negative infinity. If there's no barrier for the biggest number, it's going to be positive infinity. Okay, you can a way to think about that is just think about an arrow. It goes all the way to positive infinity. Here, less than goes all the way to negative infinity. And that only works if you have the variable on the left side. Yeah, there you go. Let's put that on the notes. Let's look at some more. Crop. Let's put one with a barrier. Actually, let's do one with that doesn't have the less than or greater than. We could do 4. So let's do 4 and then 6. All right. So 4. What variable do we have? We don't know. So let's just choose any variable. Let's choose x such that. And then we want to write a rule. Now this one we have to come up with it. So this is the smallest number, and then it goes on forever. Goes on forever, just like in Sandlot. All right, love that movie. And yeah, so how would we write that rule? X is the smallest number, so we want all the numbers that are bigger than negative 4. So x is greater than negative 4, but it also includes negative 4. There you go. Now the thing is with this one, uh, the thing is about this one, we want the x to be elements of, notice how it doesn't include decimals. It doesn't include doesn't include irrational numbers, rational numbers. So here we just have integers. And remember, integers is a z. Okay, there you go. Integers are the positive and negative whole numbers, kind of. Okay. And then the interval notation, we can't do interval notation because it doesn't include those decimals. So there is no interval notation. No interval notation. All right. Yeah, you can only do interval notation with the less than or greater than stuff. All right. And let's do 6 because it has that or equal to finally. And you could try number 5 and try number 3. So number 6, we have x such that, and then our rule is x is greater than negative 31 and less than or equal to 64, comma, and this is x is an element of all real numbers. All right, because it includes those decimals. That's what the greater than and less than are implying. And then here we have interval notation. So the smallest number is negative 31. The biggest number is 64. So 31, comma, sorry, negative 31, comma, 64. Now notice here we have just a less than, so there's no or equal to, so that's going to be parentheses. Here you have the or equal to. So we put a bracket on that side. And that's it. All right. So that's that. Let's see if there's any others. No, it's okay. All right. So if there's any others that you do want to go over, just yeah, just feel free to email and we can go over those. All right. So actually, wait. I did want to look at 7. So here we have the or. Okay, before we were doing all the and inequality. So here we have the or. Whenever you have or, it's going to be a little different. So our set Builder notation for 7 is going to be x is such that, then just write the rule, x is less than negative 19, or x is greater than 21. And x is an element of real numbers. And for interval notation, it's a little different because we have that or. Whenever you have the or, you want to think union. Okay, so these and inequalities, okay, and compounds, we're going to have, they're all intersections, so that's all together. So it's, but here we want the union, okay. So here we have, look at them one at a time. So look at this first one. Here, this is the biggest number, since x is less than negative 19. So that's the biggest. Okay, so negative 19 is the biggest. And that means the smallest is negative infinity. Or, and then here we have that union symbol. And here we have x is greater than 21. So it's bigger than 21, so that means 21 is the smallest. 21, comma, and then it goes all the way to the biggest number, which is positive infinity, parentheses. And that's it. So if you want to try 8, that'd be good. And yeah, I think we'll stop there.